Hey everybody, welcome back to chemistry videos, video number 6 for solutions. Today we get into the math of measuring concentration, and we call this concentration molarity. There is also parts per million and percent by volume or mass. All these are all these equations are ready for you on table T. Molarity is the big one, and it's the one we'll use in future units, so let's focus with that. So first, dilute versus concentrated. We need to understand what's going on here. So concentrated means there's a lot of solute in my solvent. If you go and take like 4 packets of Kool-Aid and you put it in the normal amount of water, you just made some super concentrated Kool-Aid. That's what concentrated means. So more stuff per volume. If there's more stuff, then there's more potential to cause reaction or more potential to cause harm. 12 molar acid will severely burn you. So versus 1 molar, right? 1 mole per liter versus 12 moles per liter. And we're going to learn how to calculate that. Okay. Dilute is the opposite. So this is a little bit of solute, a little bit. So you only put like half of a packet of Kool-Aid into your Kool-Aid. And now you've made some really weak Kool-Aid that doesn't taste very good, doesn't have much flavor at all. Okay, so that's what dilute means. Hence 1 molar. That'd be much safer for students to handle. I give you guys even less than a molar, so that if it gets on your skin, it really doesn't burn you in any way. It might make you itch. And isn't that safer for everybody? So that's how we do that. All right. Molarity by definition is moles of solute over liters of solution. So yes, moles is not going away. We will be dealing with moles for the entire year. It is a big time chemistry thing. So eventually, if you're struggling with moles, you will hopefully figure moles out. We keep going. So it's moles per liter, straight up. These are the numbers. How many moles, how many liters? The moles is of solute again. The liters is of the entire solution. Okay. Parts per million. This is the mass of the solute over the mass of solution times a million. This is in your reference tables, and this is what we call ppm. This is for very, very, very low concentrated stuff. So like we would measure phosphate in the lake in parts per million, because if the parts per million gets over like 50 or whatever, that's when those algae blooms have enough food to eat, and all of a sudden they have to close down the lake and you can't go to the beach. Okay. Mass of solute over mass of solution. This is percent by mass. Remember, percent is just part over whole. The part is the solute. The mass is the solution. And the key trick here is it's the mass of the entire solution. And this is what we call percent by mass, of course. Okay, you only really need to write that top thing. Mass of solute over mass of the entire solution. This one you have to add up, and you'll see when I do the calculations. Same with volume. Volume of the solute over volume of the solution times 100. When you see percent in front of any of them, it is part over whole times 100. Part is always the solute. Whole is the whole solution. Okay? Okay. On to some sample calculations. So I have my molarity equation. It's not a calculation, it's an equation. I have my number of moles given right off of the reference tables right in front of us. Okay. I have in the problem 2 moles of H2 are dissolved into 4 liters of water. Well, 2 moles is my moles of solute. Okay. 4 liters is my liters of solution. Molarity is moles over liters, so it's simply 2 over 4, which equals 0.5 molar. Capital M is molar. Okay. Good. Now, if I can go forwards, I can go backwards. Next problem, I'm given a 4 molar solution that's prepared in 5 liters of water. So I just know 2 different variables in the same equation, guys. 4 molar. So my molar solution is 4. My liters is 5. I know that molarity 4 is going to equal some number of moles over 5 liters. In this case, I'll multiply both sides by 5 and end up with 20. Good? Same equation. This is using the molarity equation. Okay? Okay. Here's where I have to go from grams to moles into molarity. So 2 steps. So I'm given 33 grams of KNO3, and I know that it's 101 grams per mole. Now you can do this exactly how this equation on the page gives it to you, and you can just say 33 over 101. I'm going to set it up for you in dimensional analysis, the way I taught you during class. So number of, no, I'm not. Oh, milks. I prefer to do it this way, and later on I do it that way. Again, you just plug it in, and the math is going to end up being the same. It's still going to be 33 grams divided by 101 grams, because if I need 101 to have a mole and I only have 33, I obviously don't have a whole mole, so it's going to be less than 1. And I end up having 0.33 moles. Okay, 0.33 moles I need for the next step. So I'm going to take that 0.33 moles, and I'm going to bring it down here. Now I know how many moles of solute I have, and then I go back to the problem. I find I got 10 liters. Now it's moles over liters, molarity equation. Moles over liters is 0.33 over 10. Get 0.033 molar KNO3. Pretty weak. I mean, we're talking 1 molar is, on the cusp of getting strong. So 0.003 relative, pretty weak, but completely in the realm of possibility of how, what we could do as far as moles go. Okay, 10 liters is a lot of liquid, man. A lot of liquid. All right, so now some percent by mass and percent by volume quick equations. These are pretty much the same thing. As a matter of fact, I don't think I do a percent by volume because it's the same as percent by mass. And even though it's right, and we do parts per million. So let's get to it. So 35 grams is my part, where I have to add those things up, though, to get my whole solution. I was trying to make reference to that earlier. So the solution now is the solute and the solvent together. So there's a difference between liters of solvent for molarity and mass of the entire solution for percent by mass. So this is just going to be percent composition equation, right? Is works. So I wrote that in there because that's where that equation is the same equation for percent by mass, percent by volume. Okay, I'm going to take my part 35, divide it by 1,000 because I added those two numbers up, multiply it by 100, and I get 3.5% by mass. Okay, good. Parts per million. Notice it's 0.009 grams of mercury. Mercury is another one of those poisonous substances where we don't need a lot of it. Okay, so we measure something like this in parts per million because just very, very little amounts is what we need to get a number on. And you'll see that my number for my answer is a more reasonable number instead of like 0.000099321 with all these zeros in this huge long number that's very, very tiny. Huge numbers that are tiny don't make sense. So parts per million put it in a regular number, and then the units make it super, super small. So the mass is 0.009. The mass of the solution is, again, add them up. And this you can do both ways, and you'll see you really won't affect your calculation. You'll come out with the same answer, luckily. So this is going to be the 0.009 over 200 and 0.009 times a million, and you get 45. I think you get 44.997, which is 45 between friends, parts per million mercury. Okay? And is that it? Oh, we are done. So, all right, you got lots of practice calculations. Do you think you're going to have to calculate these on the test? Yes, so please do all of the calculations, check your work. If you make a mistake, it's okay. As long as you know what you did wrong going forward and you don't make the same mistake, then we are all winning.